Compose Campus. It's basically a hands-on introduction. Most courses offered by Google will be hands-on. You'll have multiple pathways, and in each pathway you'll have videos, articles, and you'll have code labs. The code labs part is the hands-on part. So first you learn certain topics, and then whether your knowledge regarding those topics will be tested. Let's look at the prerequisites. First of all, you need basic computer literacy, so basic jargon like functions, etc. And you need basic mathematical skills. You need a computer and headphones to do the course, but you don't necessarily need a desktop or a laptop. You can even do it on your phone. So doing it on your phone may not be the most convenient option, but it's just personal preference. And of course, you need internet connection as well. The last option is optional. Like if you have an Android device, you can test the app. But in order to test your app, you don't need an Android device. You can instead use an emulator. An emulator is basically a software which pretends to be an Android device. We'll talk more about it in the coming slides, but that's all you need. Okay, so this is what you'll be learning. You'll be learning how to build an Android app, and by the end of the course, you should also submit your own Android app. It doesn't have to be too complicated. It need not be too feature rich, but it's just a basic demonstration of your knowledge about Android development. And you need to set up Android Studio on your computer. In order to do Android development, Android Studio is not compulsory. Instead, you can use any IDE. You can even use VS Code if you want. But you'll have to install some additional packages, like additional plugins, etc. But if you use Android Studio, it will come with everything. It has a built-in emulator, and it will come with everything that you need. You don't have to install any extra plugins, basically. And you learn basics of Kotlin programming language. Kotlin is just like Java. So if you're familiar with Java, then you basically know Kotlin. There will be some minute differences in terms of syntax. And even if you only know C, it's still fine. Like most programming languages are very similar. The only thing that's new in Kotlin will be object-oriented programming. But apart from that, everything is similar. You'll also learn about Jetpack Compose, which helps us build UI components in a more simple way. Instead of using the traditional XML method, we'll be using Jetpack Compose. And we'll also provide resources for you to continue learning. So I want to know why you're interested in this course in Android development. So anyone wants to share? Just simple reason, like why you're interested in it. Like for me, I'm not interested in Android, like in terms of career, but I'm still interested in the technology, because like most types of software development are kind of correlated. By learning web development, you can get a solid grip on app development. Similarly, everything is interconnected. So what is your reason? You can even type it in the chat.
We basically want to explore app development.
Okay. Okay, I mean, we all have the same reason, right? Okay. Okay, I'll move on from this. Okay, the first unit is basically building your own Android app. You'll be, since it's the first unit, obviously you'll be introduced to all the basics. So we'll look at the first. And as I said in the previous info session, for every pathway that you finish, you learn badges. So at the end of every single pathway, you'll have a quiz basically. And when you fill up the quiz, you basically finish the pathway, so you learn the badge. Today we'll be focusing on 2 units, and that's a total of 6 badges. And the badges that you earn will show up on your Google developer profile. You just need to log in. So first we'll start with Kotlin. So in order to test your Kotlin code, you'll be in the code labs. You'll be able to run the Kotlin code. It's called Kotlin Playground, and I'll also put links to everything. Let's get started with the first topic. You all know what a program is, right? It's basically just a series of instructions that you provide to a computer, and it will execute it. So here we have a very simple example. You have a main function. Inside you have a println statement. It will print the line provided. And code is basically the same thing. There's similar definition. It's a step-by-step instruction. In Kotlin, in Kotlin, the execution starts with the main function. In some programming languages like Python, you don't need the main function, but in Kotlin, there is a main function, and the control starts here. You can say the syntax. In order to define a function, you have to use the keyword fun. This is one of the convenient features of Kotlin compared to Java. In Java, if you want to write a function, first you have to define a class, and inside the class you have to define the function. And even to define a function, the syntax is slightly more complicated. You have to write void static. You have to use all these keywords. But in Kotlin, it's very simple. In Java, every function needs to belong to a class, but there's no such compulsion in Kotlin. You can directly start writing the program starting with a function. Okay, first of all, what's a function? A function is a segment of the program that you can call at any point of time. So by putting a certain amount of code in a function, you can run the code any number of times just by calling the function. This is just to improve the modularity of your code. So as I said, to define a function, you in Kotlin you use the keyword fun, and you provide the name right beside it. Function. The name of the function should always end with small brackets, and in the curly brackets you'll have code, which is the code block. So very simple syntax. So let's say you want this output. You want to print out the string. Then how? Then what will you include inside the code block? Oh wait. First we'll discuss variables. Variables are basically just containers which hold data. So if you want to store a data in a certain container, that's what you call a variable. So in this case, we have a string. My name is dash, and I am dash years old. To fill up the spaces, you can either just write a string, or instead of giving a string, you can concatenate a variable. So the value, so by giving the variable, you're providing the value that's stored inside the variable. So whatever string you store inside the name variable will be printed along with the whole string. So in this case, if the name is Megan, and the value of age variable is 28, it will be printed out in the string. There's many data types, but the most commonly used data types are these. So first you have a string, which is basically just a series of characters. And for numeric values, you have int and double, which don't contain any decimal values. But if you want decimal numbers, you use float. Sorry, I mean you use float and double if you want to use decimal values. And you have boolean. And here's something you have to remember for using float variables. Beside the value, you have to say f, like 5.0 f. If you don't mention f, then then the compiler won't recognize it as a float value. This is just to distinguish between float values and double values. So that's something to keep in mind when you're using Kotlin. And the rest of the data types are the same data types that you see in all other languages. So I just told you what a variable is, right? There's two main types of variables. The first one is the first one is a constant variable. It's a little bit ironic because we're calling it a constant and variable at the same time, but basically it will have a constant value. Once you give it a value, you can never change the value. That's why you define it as val. You define it with the val keyword. When you say val name, it means you're giving it a certain value that will never change. If you want the value to change, then you instead use the var keyword. So here we have an example. A person's name usually doesn't change, right? So you can just use val, but the age will change every year. So you use var, meaning that it can change. The value can change. So here you provide the variable name right beside the keyword, and right next to it you provide the data type. So this is the syntax of Kotlin that you need to remember, and you assign it a value. If you put it together, here you can see an example. First we have a function. Inside that we are giving inside that we are defining a variable called name, and we're giving it a value. Now if you observe here, we're not specifying the type, because it will when you give it a string, it will automatically realize that the data type is a string. If you're programming in C, then you have to specify that the data type of the variable. But in Kotlin, it's not a compulsion, it's optional, because it can understand the data type on its own. So here we have the output of the code. It basically just prints out the string. So if you go to this link, you can start you can start doing your course. All these links and resources will be provided in the group, so don't worry about it. Are there any questions up until now? You can even type it in the chat box. Okay, if there's no questions, I think we can move on. Next we have the pathway to. So this is what the interface of Android Studio looks like. On the left side, you have the project view. It will list out all the folders. It will list out all the directories and the files present in the directories. If you observe, this is very similar to VS Code, right? On the left side, you have the project view, and on the right side, you have the code. So this is the basic interface of most IDEs, including Android Studio. In the top right corner, you have these three options. The third option is design. Basically, when you're building your Android app, you want to know what it looks like to the end user, right? You want to know what the screen looks like. For that, you click on this design. It will just show you the interface. You can even split the code if you want. I mean, you can split the interface into two parts. On the left side, it's showing the code. On the right side, it's showing the design. Here we have an example of a composable function. The reason why we're using the annotation called composable is because this has something to do with Jetpack Compose. If you want to use Jetpack Compose, you have to apply this annotation to the function that you write. The following function is printing the text "Hello World." Inside the function, you gave it a parameter, right? The parameter is a variable called name, and you're specifying the type of the variable, which is a string. And inside the function, you have another function called text. It's a predefined function, or rather, it's a built-in function. It just shows a text box. If you use print statement, it will print the output on the console, but the user won't see the console, right? They'll look at their screen. So if you want to present the output on the user end on the screen, then you have to use the text function. And in the text parameter, you provide the variable and it will print out the variable. So very straightforward. If you want to if you want to preview, basically, if you want to look at what the output will look like, then you'll use default preview. For that, you have to provide the preview annotation, and then inside the function default preview, you provide the code. And only then you'll be able to see the output. But in order to see the output, first you have to run the app somewhere, right? So for running your app, you need an Android device. But the problem with that approach is everyone has different types of devices, right? Some devices have newer versions, some devices have older versions, and the app won't function the same way on all versions of Android. And on top of that, different apps, different devices will have screens of different sizes. Like some devices will have a small screen, and if you're using a tablet, the screen will be in a landscape layout. So all devices should be treated differently. So to test the app, one device is not sufficient, and that's why you use emulators. An emulator is basically just a software that pretends to be a physical device, such as an Android device. Although to us, we know that it's a software, but from the app's perspective, it's as if it's running in a actual physical device. Android Studio comes with a built-in emulator, so you'll have different choices. Here you can see there's a list of various devices, right? Various Android devices, and the app functions differently in all these devices. So you don't have to test your app on all of these devices. Instead, you can test it on an old device and you can test it on a new device. Similarly, you can test it on a device with small screen and a device with a larger screen to see how it functions, and that's sufficient. So you have more settings, and once you run the emulator, this is what the output looks like. All you're displaying is a text field. If you don't like using emulators, then you can actually test the app on your physical device. For that, you have to enable USB debugging on your phone. Now everyone's device is different. Like different smartphone vendors will give you different settings. So since the settings menus are different, you have to check for your own phone. But basically, in the settings menu, you'll find this option somewhere to enable USB debugging. And by connecting your Android device and your desktop, you can run the app. But USB debugging is a security risk. So once you're done testing the app, you should disable the USB debugging. Otherwise, your device will be vulnerable. That's pretty much it for Pathway 2. Any questions? Okay, in the meanwhile, I'll share the next screen. Looks like we have no questions, so on to Pathway 3. Now we learn about a composable function. A composable function is introduced by Jetpack Compose, so you don't have to use these types of functions if you don't use Jetpack Compose. But these functions are generally used to show some type of UI components. But these functions are not used for logic. If you want to, like let's say for example, you're trying to do some type of cryptography. For that, you don't use composable function because it has nothing to do with the user interface. But if you want to display UI components, for that you use composable functions. All you have to do is you have to give this annotation at composable, and that's sufficient. It will the compiler will recognize that it's a composable function. So the same syntax, everything is same. Now we have an example. Let's say we want to create this app. The app is pretty basic. First you're displaying an image, and below the image you're displaying two text fields. Let's see how to build such an app. First, as always, you start with a function. Inside that, to display the text field, you use the text function. So the name of the function is pet name, right? So you and name is a text, so use text field. So this is the text that will be outputted. So this is what the default preview looks like, just a text field. Similarly, if you want, similarly here we are printing another text field, just like before. But the question arises, like how do you, like in what layout do you want to present the text fields? We don't have a single text field, right? We have multiple text fields. So you have to explicitly specify that you want to display them in a column. So column means they will be arranged vertically. If you want to arrange the text fields horizontally, you say it's a row. So this is the syntax to specify a layout. To use the column layout, you create a code block saying it's a column, and inside that you can display the UI components. The first function pet name will display the name, and the second function pet information will display the information. Now you might here we are using functions instead of writing the whole code. This is just to make it look more simple, more readable. This is just an abstraction. So if you look at the preview, this is what it looks like. Wha- wha- One text field on top of another in a column layout. Now let's look at the resources for a directory. Printing out a text field is very simple, but if you want to display an image, it's a slightly different process. Whatever the image that you want to display, you have to specify it in the resources folder. So in the resources directory, we have a drawable directory, and inside the drawable directory, we provide the image files. So here the image is coda.jpg. This is how you access the resources. Now resources need not just be images. There's different types of resources, like even fonts are a type of resources, for example. So in order to access those resources, you can this is the syntax. First you say r, which is basically an alias for resource directory. Inside resource directory you have the drawable directory, and inside drawable directory you're trying to access the file name coda. So once again, to display the image, we'll start with a function. You assign the following value for the image. Use the function called painter resource, and inside that you have to mention what image you want to display. So this is just a variable, and if you want the variable to contain the image, you have to use painter resource function. To print out a text field, we use the function textWrite. Similarly, to print out an image, you use the function called image. Inside that we have to provide the values for these two parameters. The first parameter is painter, and the second parameter is content description. You just assign the image variable to painter parameter, and you can give it a description. Giving a content description is not compulsory, it's optional. But you might have noticed, like when you go to certain websites, when you right click on an image, you can see the name of the image, right? If you go into details, even when you hover your cursor on an image, it shows the name of the image. So that's why you use content description, but it's not really that necessary. But you have to specify what image you're using. For that, painter painter parameter is necessary. As usual, we're laying them in a column layout. First comes the image, and below the image comes the pet name, and below it comes pet information. As you can see, it looks very simple because we're using functions to keep the code modular. Instead of doing this, if you write the whole code in the same function, then it can become messy. So if you're having trouble understanding your own code, then you should just try to make it more modular and more readable. And we have our first app, and that's it for building your first app. So that's the end of today's session. But before we leave, let me share a different tab. By the next session, I'm hoping that you'll finish Unit 1 and Unit 2. They're very basic. Today we discussed Unit 1. We discussed all the three pathways, and there's also three pathways in Unit 2. So by completing these six pathways, you'll earn six badges. And from the next session onwards, we'll continue with Unit 3 and Unit 4. And the next session is on 15th. So by then, I hope you finish Unit 1 and Unit 2. Even if you don't finish it, it's fine. We can continue. Do we have any questions regarding third pathway that I just explained? If you have any inquiries regarding the course, you can always interact in the group, and all the resources will be provided. So I'll end the session there.